Okay, so now we were talking about the graph of this polynomial, and we said that we needed to find. I mean, actually, let's normally what you would do, you would actually try to find some inputs outputs here. For example, something like, for example, 5-6 points, and then based on those points you would basically see the outputs, and then basically do the graph of the polynomial. But your points could actually be off, because normally there is no way for you to know basically where this graph is going to happen. I mean, so if you were to draw this, then it could be a graph, for example, somewhere up here, for example, and then it could be off, for example, by, I don't know, 100 units over here, for example, something like this, or it could be something like this. Now, of course, since the coefficient of x is a positive 1, I know that the graph is going to be up, is going to be opening upwards, meaning that it's going to be this one, but there is no way to know where it is on along the x-axis. I mean, where this point over here, which is the bottom of the trough, is along the x-axis. So then, and of course, to draw the graph of the function, you would need a couple of points over here, and then based on that you would be able to draw the function. So now, in order to make everything easier, I'm going to find the zeros of this polynomial, and then based on that I'm going to then enter some input output points, and then or actually go between the zeros and then draw the graph of the function. So again, what I'm going to do is find the zeros, and in order to find the zeros you'll have to basically factorize this polynomial. And to factorize, you can again write this as I think actually we did this. So you would write this as x squared minus 4x plus x minus 4x plus x is equal to minus 3x minus 4. And then you could take these two terms together and these two terms together, okay? And then you would write this as, from these two terms you could take an x out, x plus 1, and from these two terms you could take a negative 4 out, so that is x plus 1 again. And then you can write this as x minus 4 times x plus 1. And then based on this, this is all basically y, y, and y. And now if you want to know where the zeros are, you have to set this equal to 0, meaning that you have to basically, if you have some polynomial p of x, we said that if k is a 0 of this polynomial, then p of k is equal to 0. Okay, that's basically something like a definition. So if p of k is supposed to be equal to 0, then I have to, and p of k is basically your polynomial, then if I set it to 0, x minus 4 times x plus 1 is equal to 0. Now in order for this to be equal to 0, either this one is 0 or this one is 0. So you get x is equal to 4 or x is equal to negative 1. Okay. So then what happens is that your graph would be something like this, and then one of your roots is x is equal to 4, so that's 1, 2, 3, and 4, and one of the roots is, or one of the zeros is negative 1, so that's negative 1. And then you know that basically your graph is opening upwards, and then you would have the bottom of the trough is going to happen somewhere, not somewhere, but exactly between these 2 points, because the graph is actually symmetrical. So is going to happen exactly between these 2 points, so that's going to be equal to 1, 2, 3, 4, 5 units. So that's going to be so this is 1, 2, 3, 4, 5 units, so 2.5. It would be right over here, and that's actually 1.5, which is equal to 3.2. So at x is equal to 3.2, that trough is going to happen. So if x is equal to 3.2, then p of 3.2, if you call this actually p of x, for example, p of 3.2 is going to be equal to 3 by 2 whole squared minus 3 times 3 by 2 plus minus 4, and that's equal to 9/4 minus 9 9/4 minus 4. And if I take a LCM of these two as 4, so that's 9 minus 18 minus 4, which is equal to negative 22 plus 9 is equal to negative 13 fourths. Negative 13 fourths is the same thing as negative 3 times 4 is equal to 12, so negative 3 and 1/4, so 12 13/4. So 3 and 1/4 would be right over here, 1 2 3, and then 1/4 would be somewhere over here. So this is negative 3 and 1/4, and then that happens at this point. So let's say that this will be basically your graph, something like this. So this is going to be your graph. Okay, and just to make sure that we didn't do anything wrong here, x squared minus 4x, x squared minus 3x minus 4. So x squared minus 3x minus 4. Oh, it's somewhere around. I think I made a mistake there. That's negative 6.25, 6.5. I think I made a mistake over here. So 4. Oh, okay. I think I made a mistake over here. Okay, so you have the LCM is 4, so that's 9 minus 18, and then 18, and then 4 times 4 is equal to 16. I'm sorry. So that's equal to 16 plus 18 is equal to 20. That's equal to 20, and this is 14. So 18 and 16, so that's 8 plus 6 is equal to 14. 1, that's 34, negative 34, plus and 9 is equal to negative 25, I suppose. Negative 25 fourths, which is equal to, now my mind right now is not in a very calculative mood, so 9 minus 18 minus 16 is equal to negative 25 fourths, and that's equal to 4 times 6 is equal to 24, so 6 and 1/4. That's negative 6 and 1/4, and then this point is supposed to be, of course, 6 1/4. Negative 6 1/4. Okay. Now, it doesn't really matter right now where this point happens to be. Of course, your graph has to be right, but this is negative 6 1/4. But the important thing to see is that basically your graph goes through the the graph goes through the x-axis at 2 points over here, and you have basically 2 zeros. And let me check to see whether there is any important information that I have missed here. Okay, so again, just to give you a summary of what happened here. Basically, what you saw was that you had this polynomial here, p of x is equal to x squared minus 3x minus 4, and this parabola over here, and I want to basically erase all of these things now. You know basically what happened here. Just to make sure that we understood all that was happening here, we got basically based on what we did, we got the graph of the quadratic polynomial. This was called the quadratic polynomial as this graph over here, and you see that the graph is opening upwards, meaning that, and the graph could have basically two different states, either opening upwards or downwards, meaning that it could be something like this, it could be something like this, could be something like this, or it could be something like this. If you have ax squared plus bx plus c, if your a is greater than 0, then you will have this kind of situation where your graph opens upwards. If your a is less than 0, negative, then your graph will open downwards, as you can see over here. Okay, so that's one thing. And then through factorization we found the zeros of this polynomial, which were -1 and +4. And as you can see, then and this point over here is the coordinates of this point is -1, 0. The coordinates of this point is 4, 0. And you can see that those zeros that we found basically are the x coordinates of the points where the graph of the polynomial goes through the x-axis. So that's also, or basically intersects the x-axis. So that's basically the important things that we need to note here. And then in the case of a second degree, in the case of a quadratic polynomial or a second degree polynomial, you could basically have 3 cases, meaning that you could have basically case 1, you could have two distinct zeros here, as in the case of this polynomial that you saw over here. So your graph could be basically either, for example, something like this, in which case you will have these 2 zeros over here opening upwards, or it could be something like this opening downwards, where you would have 2 distinct zeros, or basically 2 distinct roots for your polynomial. And you could have another case which in which you will have basically only one zero, only one. Basically, you have the case 2 where you have 1 0, and that happens basically when your graph basically happens to be either something like this or something like this. Let me close this window here. It's just that the noise doesn't let me work. Okay, so then in this, basically in this case, you will have only 1 0 because the as you can see, the graph touches the x-axis only at one point, only at this point over here, whatever you want to call it, the peak or trough or whatever you want to call it. Meaning that these 2 points that we saw in the previous case, these 2 points are now actually happen to be coincident, and then that 2 coincident points is basically another way of saying that it's just only 1 point. And then you could have another case as well where you have where you have basically no zeros, and that happens if your graph happens to be, for example, something like this or something like this. You see, the graph doesn't really intersect the x-axis in any way, so you have no zeros. And in such cases, you would still find some roots related to these polynomials, but the roots are or the zeros are said to be not real. And in order to solve such cases, you would need to have some knowledge of imaginary numbers and complex numbers and things like that. We will get to that shortly. Okay, so basically your graph happens to be completely above or below the x-axis. So basically, you could either have 2 distinct zeros, as in the case of these polynomials here, or 2 distinct zeros, or basically 2 equal zeros. Basically the 2 distinct points become coincident, and then you will have 2 equal zeros. And or basically you will have no zeros, as in the case of this, as in the case of these polynomials over here. And this also means that this and this whole situation that you see over here also means that a quadratic polynomial of degree 2 can have at most 2 zeros, meaning that it could be 1 0 or it could be no zeros, but at most it could be 2 zeros over here. So now let's go and talk a little bit about polynomials of degree 3, or basically of cubic polynomials. So in the case of cubic polynomials, or basically polynomials of degree 3, what happens is that For example, let's say you have a polynomial p of x is equal to x cubed minus 4x, and x cubed minus 4x, basically you could basically try a table of these values, and then of input output values, but if you draw the graph of this polynomial, it's going to be something like this. I'm going to save you the time, because I mean, my goal is not to teach you how to draw graphs and things like that, but at least not right now. So let's say that you have 1, 2, 3 and 1, 2, 3 over here, and then you have 1 and 2 over here, and 1 and negative 2 over here, and this point, there is negative 1 and negative 3, so there would be 1 point, that would be 1 point, that would be 1 point, and then negative 1 and 3 would be 1 point, and then this would be 1 point. So your graph is going to look something like this. Okay, so it's going to be something like this. So it's going to be something like this. Okay, so now this point is negative 2 comma 0. This point is negative 1 comma 3. This point is 1 comma negative 3, and this point is 2 comma 0. Okay, so you see that this graph goes through the x-axis in 3 distinct points, meaning this point over here and the origin, and also this point over here. So you have basically 3 distinct points and 3 zeros over here. And of course, in order to draw the graph of this function, what you can do, in order to get the zeros, basically, you can take an x out here. So you can write this as x times x squared minus 4, and x squared minus 4, you can write it as x squared minus 2 squared. Okay, and then this is the same thing as a squared minus b squared, and that you know is equal to a minus b times a plus b. Okay, so then you can write this as x times x minus 2 times x plus 2, and then from there you know that your roots are, if this is equal to 0, then if x times x minus 2 times x plus 4 x plus 2 is equal to 0, then either x is equal to 0, or this is equal to 0, which means x is equal to positive 2, or this equals to 0, which means x is equal to negative 2, and that gives you negative 2 here, 0, and positive 2. And that basically means that and then there are some ways to actually draw the graphs of these polynomials based on the degree of the polynomial, and there is other basically considerations to make. There is also other considerations, but at the end of the day, you will be able to do the graph of the functions in your head. I actually did a whole complete course on these polynomials and you can actually find that course on Udemy. So if you go on Udemy and check for the course was called Polynomials Algebra and Trigonometry, polynomials or something like that. If you ever need if you ever want to find that course, if you write me some comment or something over here, I'll tell you about that course. You can go over there and find out more about these polynomials. But at the end of the day, we are going to cover these polynomials in depth in the coming videos, so you don't need to worry about that really. So basically that's going to be the graph of for example this polynomial here of degree 3, which is a cubic polynomial. Now now again, with like the case of quadratic polynomials, we can have some other cases here as well, meaning that, for example, there are some polynomials that there are some cubic polynomials that have, for example, only 1 0, and that happens in the case of x cubed, for example. Let's say you have p of x is equal to x cubed, or let's say that p of x is equal to x cubed minus x squared, for example, or for example g of x is equal to x cubed minus x squared. So in the case of these two polynomials, what happens is that p of x is equal to x cubed is going to be some polynomial like this. It's going to be 1, 1 and negative 1, negative 1 and the 0 over here. And it's going to be something like this. That means that the polynomial goes through the x-axis actually only at the origin. You have only 1 0 over here. Or the other polynomial happens to be something like this, meaning that you have this 1 over here, and then your polynomial actually kind of goes this way, over here, and then keeps increasing like this, something like this, and this is x cubed minus x squared. So you have 2 roots over here. But what that means is that, and basically the other polynomial that we had, what was that? X cubed minus 4x. If we had, let's say, f of x is equal to x cubed minus 4x, that was basically some polynomial like this. That was some polynomial like this, I suppose. So it was something like this. Something like this. It was something like this. Okay, so basically we had these 3 points as the zeros. So what that means is that a polynomial of degree 3 can have at most 3 zeros. And we said that a polynomial of degree 2 can have at most 2 zeros. Okay. And of course you can say that you can generally say that a polynomial of degree n can have at most n number of zeros. Okay. Now let me see if we have anything over here that I need to cover here. So basically, in general, given a polynomial p of x of degree n, the graph of y is equal to p of x intersects the y-axis at most n points. Therefore, a polynomial p of x of degree n has at most n zeros. That's basically the important thing here. So that's basically Now let me stop here for just a few seconds and see what's going on. I'll be back in just a few moments. Okay, so it seems that we have not much important here to talk about anymore. So in the next video we will talk about the relationship between zeros and basically coefficients of a polynomial. So I'll see you in the next video. Thank you.